This video will cover the first section of 4.5, 4.5a, which is integration by substitution. So if we want to integrate something that is a composition of functions, so when we took a derivative of composition, we used the chain rule. So for instance, if I take the derivative of f of g of x, then we would say that's f prime of g of x times g prime of x, okay? So that's called the chain rule, and that's how you take the derivative of the composition. But now, what if I want to take the integral of the composition? So that is, if I take the integral, and remember the integral is finding the function whose derivative I'm given. So for instance, what I'm going to put inside the integral is f prime of g of x times g prime of x dx. And so if I were to take the integral of that, then whose integral would that be? And that would be f of g of x. So what we're looking for is something that when I have the integral, I have this inner function and then the derivative of that inner function out to the side. So in other words, I want to undo the chain rule. So to undo the chain rule, first we want to identify some inner function, and we're going to call that inner function u. So what we really call this substitution, integration by substitution, we call it u substitution. So I'm going to call this inner function u, and we're just going to use that for substitution purposes, whose derivative is also a factor of the integrand. Okay, so you can see that here with g prime of x, that is a factor that's inside the integrand. Then what you need to find is you need to get everything in terms of u. So when I have this integral, we're taking with respect to x. So if I put things in terms of u, then I need to put everything in terms of u. So I need to find du for the inner function. Then you're going to substitute. So that means everything inside the integral is going to be in terms of u. Then anti-differentiate, take the integral, and then back substitute. All right, so let's see how this would look just theoretically. So if I give you the integral of f prime of g times g prime, which is what would happen if I do the chain rule for derivatives, then what you would want u to be is this inner function, so g of x. So that's going to be your u. Then you want to find du. So what that is if u is g of x, then du, and when I take the derivative of u, you take the derivative with respect to x. So du with respect to x is the derivative of g. So that's going to be g prime. Okay, so if I want to substitute this, I want to figure out, see this g prime of x dx. If I move this dx over, then you get that du is equal to g prime of x dx. And then that would substitute completely. So g of x becomes u, g prime of x dx becomes du, and then you just substitute. So now we have f prime, instead of g of x, we have f prime of u, and then instead of g prime of dx, we have du. Okay? So now you can take the integral of that. So the integral of f prime is just simply f. So you get f of u, but then, or plus c really, and then f of u, you put that back in terms of f, so that's f of g of x plus c, which is exactly what we saw in that first example, backwards. Okay, for a first pretty easy example, we want to evaluate this function. Now, there's no way that you could take the integral of that without using u substitution. Well, I take that back. I guess you could. You could take 7x squared plus 3 to the 8th power and multiply that out 8 times. But that is not what I want to do. So you want to look for the u, the inner function. So the inner function here is 7x squared plus 3. And then when you take du, you want to see if that's one of the factors of the integrand. So when I take the derivative of u, you get 14x, which is exactly what I have here. Now, I know in the first example I said du over dx, but I typically skip this step and go straight to 14x and then just throw a dx on the end. So when I take du, I just put a dx on the end. I typically will skip that step. All right, so now I have my 14x dx, which is going to be my du. So rewrite it, substituting everything in terms of u. 7x squared plus 3 is u, so that's u to the 8th power, and then 14x dx is just du. And now this becomes very easy to integrate. So this is going to be u to the 9th power with a coefficient of 1/9 plus c. You do not want to leave it in terms of u, you want to back substitute back in. So 1/9 of 7x squared plus 3 to the 9th power plus c, and that is my answer with u substitution. Okay, second example here, a little bit different. So I have x times cosine of x squared. Now the inner function here is x squared. And when I take du, you get 2x dx. So I've got part of this. I've got the x sitting here, and I want to rewrite this. Let me show you. Where I have the f of u first, and then the du second. So x dx. So you can see that I've got the x dx, but I don't have this 2 here. So what you can do is, in order to get the du, I can still have a constant multiple in my du. It just can't have any x's in it. So if I want x dx, which is here, then all you have to do is divide by 2. So x dx is simply equal to 1/2. So when I substitute x dx, I'm going to put in 1/2 du instead of du. So now I'm going to rewrite the integral, and you have cosine of u times x dx, we said, is 1/2 du. Now before I integrate this 1/2 du, it is being multiplied by the integrand. So what you can do is that 1/2 can actually come outside of the integral, since it's a constant multiple. And that's what I like to do just to avoid confusion. So the 1/2 I bring out, and then you have cosine of u du, and now you can simply integrate. So that's going to be 1/2 sine of u, and I can go ahead at this point, plug back in my u is x squared plus c, and that is your final answer. Now you can always check to make sure that your answer is correct by just simply taking the derivative. So if I were to take the derivative here, you would get 1/2. Derivative of sine is cosine of x squared times 2x. 1/2 cancels out with 2, and I'm left with x cosine of x squared, which is what I started with at the beginning. So you can easily check your answer if you want to. Okay, the last example is still different than the other two that we did. So if you went with the same reasoning by using the inner function as our u, that would be 2 minus x here. So then du would be negative, the derivative of x is 1, so 1 times dx. All right, now this poses a problem because you have this x plus 1, which is our factor, which when I took du, there's no more x's involved. So this is a little bit different. We didn't do it incorrectly. We would still use u as 2 minus x, but we're going to have to be a little bit more creative with how to get everything in terms of u. So this is still fine, du equaling negative dx. And actually our dx here, we're going to go ahead and say dx is equal to negative du. Okay, so I've got my u. 2 minus x is u. dx we're taking care of is negative du. Now the only thing left that's not in terms of u is just this x. The plus 1 doesn't really matter. I'm okay with numbers. It's the x's that I don't want. So what you have is you have an equation that relates u and x. U equals 2 minus x, so if I solve this for x, that would be 2 minus u. So now I have everything in terms of u. So we found x. X is 2 minus u, so I'm going to put 2 minus u in for x plus 1. Okay. Then the square root, 2 minus x is u, and then dx is negative du. Okay? So again, you're just taking everything that's in terms of x and replacing it with something in terms of u. So I'm going to clean this up. This negative right here, I'm going to pull that out front of the integral. So then, and then 2 plus 1 is 3 minus u times the square root of u du. Okay? Now that square root of u, when I'm simplifying this, this still looks like it might be complicated, but we're going to have to simplify this before we can take the integral. We don't do use substitution again for this problem. All we do is just distribute. So that u to the 1/2 is going to distribute before we can take the integral. So that's going to be 3u to the 1/2 minus u to the 3/2. And then when we integrate, we get negative u to the 3/2. 3 times 2/3 would just be a coefficient of 2, minus u to the 5/2 with a coefficient of 2/5 plus c. Then for our final answer, we're going to replace with u. So u is 2 minus x. So this would be that would be our final answer. Okay, so I've kind of shown you 3 different kinds. The first example that I showed you was actually really, really easy. That is that when I took du, the du was already in the problem. So let's go back and look at that one. So on example 1, like I said, if you have u and then it gave me exactly du. A lot of times that doesn't happen. We're going to have to tweak it. Example 2 is probably more common, like what you would have to see with this multiple of 2. And then what you'll see probably not as much of the time is one where you have example 3 where you have to get x back in terms of u. Okay, so what I want you to do is I want you to take these 6 problems, and I want you to try these before you come to class next. So, and what we'll do with the class is we'll just compare them and talk about them.